submarine was cruising at a depth of 110 meters. It then rose at 5.5 meters per minute for 10 minutes. This becomes a challenge because we're going to be doing math, but it's also within English, so we have to read the question and understand this. So we've got a submarine at a depth of 110 meters. So we can imagine, I like sometimes drawing pictures. Here's water. I don't know, is that what a submarine would have, like a antenna thing so it can sneak up and peek? And you need notes?
Yeah.
I got it. And this depth is 110 meters to start with. You're welcome. And then rises 5.5 meters a minute for 10 minutes. So every minute it's going to go up. It's going to go back up. 5.5 meters every minute. So how do we show this with math? Okay, first of all, we've got two different directions, right? It's below by 110 and then it's going up. So sometimes when we want to show something is below, we write that it's minus 110 to show the minus saying it's below the surface. So sometimes negatives are nice that way because a negative number shows that it's below. And then we're going to add 5.5 per minute for how many minutes? 10 minutes. So I could show this in two different ways. I could go plus 5.5 once, minute 1, plus 5.5, minute 2. Or if it's going to happen 10 times, I can just go and say 10 in brackets, and there would be a multiplication there. We can go type this into our calculator exactly as we see and push enter. Or I'm going to do it mental math. If you multiply by 10, that moves the decimal place over, so we get minus 110 plus 55. And then I get minus 55 meters in the end. It's a word problem, so I can write a sentence. The sub's depth is 55 meters below the surface. Now it went up 55 meters in 10 minutes, and now you're still 55 meters to go. Does it make sense that it would take another 10 minutes to get back to the top? So if we think about our number line, here's 0. Here would be minus 110 on your number line. And plus 55 would be going in this direction, 55. So we're going to get to a new number that's getting closer to 0. And that new number is minus 55. The negatives are so hard to visualize, eh?
Does that help when you see it on the line?
Kind of.
Yeah.
And you'd be able to use a calculator on this
Have
one.
a calc.
But one of the things that we did yesterday that I think is really important for your brain is you should try to do each thing in your head before you hit enter on the calculator. To get an idea, is this somewhat right?
Like my brain instantly goes, I have a negative 110 and a positive 55. What do I have more of? Negative. So I know that it's going to be negative.
That's a nice way of thinking about that. You have more negatives here than you have positives, so when you're adding things
And how
together.
much more? Right?
And the last word problem that we're going to do together, this one's kind of weird. In your notes, I have space above it and not really space below it, so you can write some of the work above it. 2 wooden poles measure 2.45 meters and 1.23 meters in length. Okay, so what we have here, again, a lot of times in a word problem, drawing a picture is really, really helpful. But I'm kind of fussy. So, this kind of brownie, ooh. Are you happy with that brown for a stick? Okay. So, I have one wooden pole. This is my longer one. It's 2.45 meters. Then they're going to attach them, but they have to be overlapped. So I'm going to take my other wooden pole here. It's not quite as long. It's 1.23 meters long. And then I got some green string here. And I tied them up really tight with a nice little bow. There we go. So I can take it apart easily afterwards.
It's not just numbers with JR people, it's art too.
Art class. I'm not sure. All right. And this part from here to here is 15 centimeters. How long is it from here to here now? Why can't we just add the two numbers together? Why can't I just go 2.45 plus 1.23?
Into 15 centimeters.
Because there's a little bit of the overlap, right?
So we just add it to that. Would you take out the 15 or no?
Would that work, right? If I took this one, oh wait, look at this. I love this. Right? If you had it here and joined it up that way, if you just added those two together, it would be too long. Does it make sense that this is 15 centimeters extra when I put them end to end? So if I added the two together, the 2.45 and the 1.23, that would be too long. What would I have to do to bring it back? I'd have to subtract the 15 centimeters. Now this was in meters. This is in meters. Why is this wrong when I show my math that way? It's the right idea.
Did you put the centimeters?
Because this, if this is meters, and this is meters, and this is centimeters, now I can't do the math because I'm talking in different units. It gets tricky to say how big it is. So I need to change either everything to centimeters or everything to meters. How do you change 15 centimeters to meters? 0.15. Because there is, if you look at a meter stick here, we have 100 centimeters.
Be dividing it by 10. But for every
Right.
meter is 100 centimeters.
Here is a meter stick, which is 100 centimeters. 15 out of 100. 15 out of the 100. Oh my goodness, there's our fraction. We can change that fraction.
It's just-
Okay, I needed to use more tape.
You weren't kidding, you wore the J's after.
Yeah, I had to wear it.
They barely won.
I know, it was scary. It was scary but exciting. And now I lost
Now,
my pen. There.
why put it meters in this particular case?
It's easier.
Read the last sentence of
Yes.
the problem.
Wait, do you have to put it in meters even if it says meters at the end?
This says what was.
In meters, you have to, like, or
So in order to do the math, we'd need to be in the same unit all the way along. Okay? This would be the same. Okay? This is figuring it out in meters. And if we did this, I would tell you to use a calculator.
But you are gonna do 3.68 minus, yep,
You know what I did? I took the 15 off of this one as the easiest. Because I made this 2.3.
smart.
2.3 plus 1.23 makes 3.53. But you could have done it as 245 centimeters plus 123 centimeters minus 15 centimeters and got 353 centimeters as well.
But then, you'd have to go to meters.
And then you have to do 2 decimal places over to change it back to meters. So it's kind of nice to do it in meters at the beginning, but then for sure you'd be like, I think I should use a calculator with all those decimal places. Try it in your head again, because I just showed you, like, there are some things like, oh, there are some things that make it easier for mental math. But I know most of you don't love mental math, so that's okay. But working in decimals is super important. And one of the common mistakes is I'm going to give you 3 decimals, and I want you to tell me which one is the biggest. All right? The 0.4. The 0.4 is the biggest, but sometimes our brain will do what to us? Like even looking at these first 2, what does your brain want to trick you with?
Just because it has more numbers, it seems bigger.
Yeah, this one looks like 37, doesn't it? And this one looks like 4. Just because it has more numbers, it seems bigger.
since it has more decimal places, it's smaller, right?
No, because watch this one. How about if I do 0.23 and 0.421? Now the one with more decimal places is bigger. 0.421 is bigger than 0.23. So, how do we compare decimals when they're like this? Well, this one goes to the tenths. This one is only, this one goes to the tenths, this one goes to the hundredths. If you really want to compare them, you should have the same decimal places for each. By add a 0 there, now 40 and 37, is it pretty obvious that 40 is bigger? And if you wanted to compare it with this one, 4,000, 3,700, 2,358, now the 4,000 is obvious that it's bigger. The first decimal place is the most powerful. So some people compare by just looking at the first one. 4, 3, and 2. Biggest, second biggest, smallest. Sometimes people compare by having the same amount of decimals. So with the 0.23, when I'm comparing these two, I could add 0.230 and 0.421. Then I'm looking at the thousandths for both of them. This one is, as a fraction, 421 over 1,000, and this one is 230 over 1,000. Which one has more pieces? Can you imagine a chocolate bar with 1,000 pieces? That would make me happy for many days, I think. Unless the pieces were really, really tiny, then I would be sad. I was trying to think, what kind of candies even come close to getting 1,000 pieces?
I had one that had 500 pieces before.
Yeah, a chocolate bar?
Yeah, my grandpa got it for me.
You gotta hook me up. Where do you get that?
I know candy, but not chocolate.
Like I would say, yeah, what kind of candy?
Nerds.
Nerds is what I thought of too. Like you get a lot of, I've never
What's that fizzle
dumped it
stuff?
out and counted them out.
What's that fizzle stuff? Pop rocks. Could be,
A big bag of Skittles.
Yes, the
Think
big
so?
ones.
yeah,
You got big enough. Could have.
yeah. Skills are good.
So, I'm going to, the assignment that I'm going to give you, and you're going to get as much done before the end of class and hand it in, you're going to compare decimals. I'm also going to give you a chance to compare fractions. So if I say, which is bigger, 5/8 or 4/7? And there's going to be a space in here, and you can either put bigger than, less than, or equal. And what I'd like you to do is to use a calculator. And you type it into your calculator, 5/8, you will get 0.625. Type it into your calculator, and 4/7, you will get 0.581427 repeated.
You shouldn't know that, people. They are sick for knowing that.
You just have, but that's what you get when you type it into your calculator. Now, which one's bigger? And again, which strategy do you like? Do you like having the same amount of decimal places? Or do you like just looking at the first one? If you just look at the first one, what's bigger, 6 or 5?
That's
6. So we would write this symbol in for this is bigger than that. Is it better to get 5 out of 8 on a quiz or 4 out of 7? 5 out of 8 is better. Do you know why? Because if you answered 7 questions, got 4 right, and then someone said, we'll give you one more question. If you got, you'd have to get 100% on that question. One more right, one more question. So with that same logic, 6 out of 9 is even better than 5 out of 8. That's a way of thinking about it. Okay, so that's all on our video for today. Kept it nice and short because we are